Okay. Anyway, last time we already telling you about a transistor. Okay.
Hey, Mr. Pham, make your screen just a little bit bigger.
Okay. Let's see. Okay.
Yeah, that's better.
Okay. So basically, what you need to know, basically, you get the NPN, NPNP. Okay. And if you're looking into the symbol, okay, that is NPN, the Bay collector admitter, and the current flow at the golden IB, Bay current coming in, IC collector current coming in, and IE emitter current coming out. And PNP, and you can see for the current IB leaving, IC leaving, IE coming in. So basically, you know this is just a diode, okay? From the base to emitter, just a diode, okay? In here, this is a symbol for the transistors working in the lab, okay? They're telling you which one base collector emitter, okay? At the base, you get a diode go to collector, and a diode go to emitter. That for P and PN, and PNP will be opposite, okay? Just opposite. And now if you're looking into the circuitry here, at the base you get the DC voltage, VBB. And at the collector you get the VCC, okay? And then you can see the difference between NPN and PNP. The difference will be NPN VBB positive here, PNP VBB will be negative, opposite. You see that? And also VCC, okay? They also opposite. And the current flow, IB in, IC in, IE out, NPN, PNP, just opposite. They want to get beta current gain and IE for transistor equal IB 50 microamp, IC 3.65. If you want to get the beta, and the beta will be equal IC over IB, okay? So that's why you can get a beta. And after you get a beta, you can get IC, okay? IC already given. You can get IE. Ah, okay, so that is the formula to calculate the IE, okay? 1 plus IB time 1 plus beta time IB, okay? And they given you this circuitry, okay? Let's see. I try to erase that. Okay, you get the VBB, RB, okay, and basically they given you all of the formula here, okay, in order to calculate the IB and VC and IC, okay, and also IE. Every formula they already given to you, okay, and this is example. You try to working on that. This is the answer. Okay. For the transistor, you can get first thing to get a cutoff, active, and saturation. That is the region they will be working on. Cutoff yields in switching application. Okay, cutoff used in switching application. Active, using for linear amplification. Okay, and last saturation used in switching application. Cutoff and saturation, they will be working together. Okay, and they tell you cut off diode from B to emitter is off. Active diode from B to emitter is on. And diode from B to collector is off. Saturation, both diodes are on and VCE equal 0 volt. For the transistor cell, what is VCE when Vin equals 0? Vin equals 0. We know for sure no current IB. Okay? They're telling you the diode here not working. Okay? And the transistor will be off. That means open. Collector here open the bay, open at meter. So when they open at the collector, the current from 10 volt go to RC equals 0. No voltage drop. That will be telling you VC will be equal 10 volt. Okay? What is VCE when Vin equals 0? VCE basically equals VC minus VE. VE 0. VC 10 volt. Okay? That means VCE equals 10. Okay? And what is the minimum value of EB to require saturate in here? Vin equals 0. Transistor off. IB equals IC equals IE equals 0. Therefore, VC equals VCC equals 10. Voltage drop across RC 0. VCE equals VC minus VE. Okay? That equals VCC. Then transistor saturate VCE 0. Okay? Then I saturate equals VCC divide RC equals 10 milliamp. Therefore, IB equals IC saturate divide to beta. So that's telling you IB equals 50 microamp. Okay? When the transistor is on voltage across RB, VRB, okay, equals VE minus VBE. That means the diode from the base to emitter 0.7, and that given you 4.3 volt. Then RB maximum equal RB divide IB minimum. Okay, IB minimum we already calculate 50 microamp. So that's telling you 86K. Calculate the maximum value of RB. Okay. In order to get the maximum RB, you take the VRB divide minimum current. And make sure when you're looking into that display, try to understand. First thing, on this side here, for the current IC, okay, IC, you see that? IC in milliamp. And the other side here, that for VCE in volt. Okay. If you get a point at this point right here, they will be telling you, you're looking into the right. You can get close to IB, 80 milliamp, microamp. Okay? And if you're looking into the left, you can get the current here for IC. If you want to know VCE, you going down here. VCE equal 10 volt. Okay? So on this display, basically they vary with the current IB. Okay? So if you get a point here, you know IB, you know IC, you know VCE. Okay? Okay, so if you get a point A here, this area, small one, that will be saturation. Every part in here, active, and the little one at the bottom here, that will be cut off IB equal 0. Okay? Okay, they've given you a little more. Okay? This is the active region. Okay? Active region. This part here, saturation. Okay? After point C here, this will be a breakdown region. So basically, transistor will be working in this area for amplifier. Okay? This is the saturation. And this part in the bottom here will be cut off region. Okay? We already telling you, you get a cut off region, saturation region, and active. So active must be in here. Okay? If you get IB, you're able to get VCE. You're able to get IE. Okay? So depending on application, you make a switching on and off. They be on saturation and cut off. If you want to be amplifier, they must be in active region. You see, cut off. If the transistor cut off, they will be open. Okay? That means collector to emitter open. And then saturation. If the transistor saturation, then the collector connects to emitter. So either they open or they connect. That normally the switch. Okay? You turn it on, they connect. Turn it off, they open. Okay? So that's why the talking amplify saturation cut off. So we just go to saturation and cut off. Now, for this circuitry here, okay, they want find IB, IC, IE, V, E, VB, VC, VCE. Okay, I try C. They already given you the solution here. You better get the time go over. It will be the same problem. And I already given you the solution here. Okay? You need to working on. If you get any question, just let me know. They want to know Q point for circuit so given beta. That means you need to calculate voltage IB. Okay? IC, IE, and VCE. Okay? So let's see. Okay, so you can try. They calculated for you here. Okay? You need to read it. This is another way. Add me the feedback. Okay? Better than buyer. Q point still move. Not popular. That means it's a different way to connect the transistor, but it's not good. Buyer. Also another one. The least predictable. Q point move with replacement. Q point move with temperature. Not practical. Just given to you. As yet to see. Okay, collector feedback. Better than emitter feedback. Q point still move. Limit application. That's why you never see they using it. To supply meter buyer. That means they're using one power and another one power. Okay? That's not good. The thing is you have to spend more money on the power supply to supply cheap meter buyer. We don't care about that. Now, we really care right here. Voltage divider buyer. If you're looking at the circuitry connection, you need only one. VCC. Okay, 1 volt power supply. They using R1, R2 connect to make the voltage divider. Instead, you have to apply the power supply to the bay. Now, we don't need that. You need only R1, R2. Then you can get VBB. Okay? In here, VBB equal R2 divide R1 plus R2 times VCC. That's just a voltage divider. Okay? And after you get the VBB, so VE, that means from the ammeter to the ground. The difference between VBB and VE is the diode, 0.7 volt. So you want VE equal VBB minus to 0.7. That's why you get VE. And after you get a VE, easy to calculate the IE. IE equal VE divide RE. And after you get the IE, you can calculate the IB. Okay? Equal IE divide to beta plus 1. R1 and R2 form a voltage divider. Okay? And you calculate IC beta times IB VRC. That means IC times RC. If you want VC, you have to take VCC minus voltage drop across RC. This is our own calculation. Try to get along with that. We're using a lot. Okay. Now, if you're looking on this one, okay, basically to say what they say, if the bare current IB is much smaller than current I2 through R2, then the voltage divider consists of R1, R2. VBB equal VCC times R2 divide R1 plus R2. Okay? If IB is not small enough to need like compare to I2, therefore more divide calculation is needed. Okay, this is using for engineering. Okay, the thing is before, one student was asking me, that means from the VBB to the round, you still get a resistor. Okay, however, this resistor too big, so all of the calculation will be ignored. However, if they want it, they can go to here. R in B. Okay. That equals VBB divide IB, where R in B resistance from VBB to the round. Okay. VBB V in B equal sorry. Hello. Yeah. Còn hết còn nguyên. Ok thôi. Không không. Đúng rồi, mở ra mà không có xài. Ok, là cái gì là ra nào? Thì cái hai cái loa đó là không xài. Đầu tiên đang xài. Còn tồn nhưng mà bố có đang xài cái đó mà. Ồ, ok, tôi được rồi. Lát nữa lúc nào nói chuyện thì bố đang dậy. Ok. Okay, we'll say VBB. That means the B equal VBE adding to IE times RE. Okay. And they calculate the VBB equal beta times IB times RE. And they calculate the R in B. Okay. So basically, they say VBB equal VCC times R2 divide R in B. Okay. And divide R1 plus R2 parallel R in B. Okay. So that is very complicated. We never care about that. Okay. But I have to prove for them. They can calculate by more detail. And now for this circuitry, what I want you, if I want VBB, you can calculate it right away. And if I want to calculate the VE, you know how to calculate it. And then IE, and after you get IE, you calculate the IB. Okay? After you get IB, you get IC. And VRC, then, okay, VC. Finally, VCE. Try to go through that and do that example. Okay. Now, another one you also need to know. Same voltage divider. However, for PNP transistor, the other one we already got through it. That's the NPN. Okay. And now we'll get to P and P. First thing, they calculate the VBB. Same thing when we calculate the VBB in the NPN. That means VBB times R2 divide R1 plus R2. Okay. And now they want to calculate the VE. Okay, if you're looking here, this is the admitter, the bay collector. VE, that means from admitter to the route. Okay? So from the admitter to the bay, you get a diode, 0.7 volt. Then you adding with VBB. That means you get VE. That's why they give it to you here. Okay? Then they want to calculate the IE. Okay. IE. Let's see. You get the admitter here. The current flow to admitter between VEE and VE. Okay. So you take VEE minus VE divide RE. That's why you can get IE. Okay. They show you here. Okay. After you get the IE, you can get the IB. Formula will be IB equal IE divide beta plus 1. IC, IB times beta. VC, that means the collector to the round will be IC times RC. And finally, VEC, VE minus VC. Those two calculations, one for NPN, one for PNP. Try to work through it. Make sure you know how to calculation. Any question? Otherwise, we can go quickly to get through it. Okay, this one. Okay, only thing is they're using negative on the tier. Okay, then if you get a time, you can go through the formula to calculate it. We don't care about that thing. And Darlington connection. Now, if you get a 1Q1 and another Q2, output Q1 connect input Q2. That's what they call a Darlington connection. Okay? The purpose is they want to get a big gain beta. You see, the first Q1 get a beta 1 and go to the second one, Q2 get a beta 2. So the gain will be beta 1 times beta 2. That means the current will be very high. When you're working with that circuitry, have to be very careful. For some reason, something short to round, you can get it burned right away. The thing is the current very, very high. Okay? And now, instead they connect outside, they make that one into the what we call a Darlington transistor. Okay? And they will be the same. Okay, so that will be cover everything for you about transistor DC. Okay? The next meeting we'll be talking about transistor amplifier. Okay? And I hope the next will be N for transistor. Okay? So, you get any question or anything? Okay, this is the first time happened during the time I'm teaching. Basically, take one, we can get only one or two, three students. Okay, normally I get 17 to 20. I'm not including one student at Tech 2 and 1 meter speed. Okay. So that never happened. I don't know. And also, I get a problem with my iPad this side. So that's why giving a lot of problem. We get a meeting, I get a meeting with the CD. Take 1 hour. Okay. So will be a good night for everyone. Okay. And hope you guys get a good weekend. See you guys on Monday.
All right, Mr. Pham, thanks a lot.
What?
Have a good night.
Okay, good night.
Have a nice weekend. Bye bye.
Bye bye.